Hey everybody, just a quick reminder before we get the episode going that your support means a great deal to me. If you are able to support the channel financially, please do go to 10percenttrue.com, hit subscribe and pick one of the packages. For £5, $6.50 a month, you get early access and ad-free access to my content. And for a little bit more than even that, you also get access to AMA and private Q&A sessions that are run directly with my guests through Zoom call at least once a quarter, probably more often than that. I'd appreciate your support. Anyway, let's get on with the episode.
And it goes up and, a few things bad happen. And eventually it's re-entering the atmosphere and all this plasma is coming off of it. And we have these beautiful, high quality images from their Starlink satellites the whole way. And it starts to tumble and things start melting and big chunks of spaceship are flying off. And then they show the control room with all the engineers that have designed this thing. And you would think that they would be like, oh no, look, oh, this is a disaster. They're jumping up and down, high-fiving each other, hugging each other. Woohoo! Because all those pressure transducers and temperature transducers and vibration accelerometer, all the instrumentation for all the structure is just pouring data into their data recorders right now. And they know exactly what's happening to this, stringer and this rib and this. They've got all the data they need to know exactly what went wrong and how to fix it. And the engineers are just, woo! and what's killing me is Elon Musk is going, woo! And he's the one who's paying the bill. He's like, you would think he'd be like, you're fired and you're fired and you're fired and you're fired. And I'm starting over with a new team because you guys can't hack it. No, he's like, this is awesome. This is exactly what we wanted to happen, right? They're not putting astronauts up in that thing. They're not even putting paying satellite customers up in that thing. They know it's going to be dorked up. But they're learning, right? They're gaining knowledge this whole time. So watch the difference in how people operate. If you, the company, is paying the bill, you actually end up testing more. If you, the company, is being paid by, say, a government contract, you want less tests because that's an opportunity to expose failure.
Super. Welcome back to 10% True.
It's awesome to be here. Thanks for having me.
This is the second part of a series on the decline of the acquisition and I suppose you would say developmental test, operational test worlds that you inhabited. You were developmental test, but I know you crossed over into OT as well, which I think is going to be one of the things that you'll talk about today. So for the audience at home, if you're listening to this, go and listen to part one. It will help make part two make more sense. So Super, in the first part, you talked about this framework that you have to describe the deterioration as you see it around the developmental test piece and the way the Air Force is acquiring and fielding weapon systems these days. And you talked about sort of 4 stages. So the first was this mergers and acquisition process at the back end of the Desert Storm. The early 1990s. The Air Force and the military in general was going to be getting less money, so they combined their organizations to make these big powerhouses, and there are 5 of those now. You talked about then the concurrent test and development of and fielding of assets, and you gave some good examples as to how that fell flat on its face. And I think today we're going to talk a little bit about I don't know if you call it the mixing of operational tests and developmental tests, but the fact that you've got OT guys doing DT and DT doing OT, and then finally we'll talk about the DevOps piece, which anybody who works in software these days will be familiar with: minimal viable product, MVP, and the way that that has then been applied to military acquisition and the programs that you've been involved with. So we're also going to transition at the end to talk a little bit about some success stories as you see them in terms of the way that some civilian companies have successfully managed to protect and enforce the developmental test piece through their development of their products, and maybe an example or two where they haven't. And then I'd like to talk about very briefly F-47, because you are you were the head of the Air Force Flight Test Center until late 2018. So I know that your brain is crammed full of stuff, almost all of which you cannot talk about. But we'll try and get an opinion from you at least on what has been publicly stated, and then we'll talk about Hegseth, his latest speech around the way that defense acquisition should work in the US, and maybe get a view from you as to which parts of that you like and which parts you don't.
Sure.
So without further ado, then, so stage 3 then was this mixing operational test development test. I said in the first conversation that you and I had obviously we talked about EF-111, and then we hadn't really maintained regular contact. But then you had pinged me to say you watched the episode with Starbaby around Light Attack, and I think Dude was the guy's call sign who was killed in an 86 weapons release profile, and you said that was something that obviously that was sort of close to your heart, but had sort of hit home to you. So can you describe then that piece and your views on it?
Yeah, that was, the accident actually happened about just a little over a month before I retired as the Air Force Test Center commander at Edwards Air Force Base. But the roots of the accident trace back much farther. I was part of that. I'm the problem because I was in charge of Air Force test and evaluation, developmental test and evaluation. Now there became a movement really, and Starbaby. And Starbaby is a very engaging speaker, very persuasive, very, he's just awesome. And we went through EWO school almost at the exact same time. We had sort of parallel careers in a lot of ways. But he and many others got very passionate about just buying stuff and figuring it out after you've bought it. And there's something to be said for that. In wartime, you hear all kinds of stories about, the Tommy who just decided to use this mine that was supposed to be for something else to blow up something completely different, and the sticky bomb from Private Ryan, and all those kind of battlefield innovations. And I remember in Desert Storm, there was an A-10 pilot who got a kill on a helicopter using a laser-guided 500-pound bomb. Now, there's no tactics manual for that. There's no flight test for that. He just decided that he could do it, and it worked. So there's something to be said for that. In wartime, I would say. In peacetime, sometimes we, what I like to say, run with scissors. There are risks that you are incurring that you really don't understand unless you kind of understand the risk business. And that's what we teach at test pilot schools, how to manage risk. Because you can't go too far in either extreme. You can't just blow off the test. That's risky. But if you over test and you just admire a problem forever, right? To go back to my BB gun example from the first part, Black Bart and his band of desperados are coming over the backyard fence, and the only thing standing between them and your home is your little blue steel beauty of a BB gun, right? You gotta have something, and you can't wait around forever. So that was a problem as the program was developing. It was called the Light Attack Experiment, and they brought in 3 major competitors, as I recall, and they needed a place to do it. And I offered up Holloman Air Force Base, which was one of my test facilities out in the deserts of southern New Mexico. I had been the group commander there. I knew all of those training ranges, and I thought that would be a good place to do this. But I was pretty adamant that we needed to have actual test pilots do the fly off. And I accidentally used the word fly off in a phone call, I remember, with all of the center commanders and the material command commander who was running the meeting. Oh, and she came down on me like, Super, it's not a fly off. And you can't say the T word. It's not a test. It's an experiment. And I was like, yes, ma'am. But in the back of my mind, I'm like, wait a minute. We're bringing in 4 competitors, and there's going to be somebody that's going to evaluate those to see which one they want to buy. So where's the experiment here, and what's a fly off? What's the difference between an experiment and a fly off and a test? Well, the real reason is there are due diligence kind of things that are associated with things called fly offs and things called tests. But for experiments, it's an experiment. We're just running an experiment, nothing to see here. It's an experiment. So I tried to get test pilots in there anyway, because I'd been around the business long enough to know that it's never easy. Even if you're going with a known product, and all of these products have been flying for a long time in other air forces. And so the Starbabies of the world would come back and say, Super, where's the risk? Let's just buy them, and then we'll figure it out after. Well, they flew them, and they came up with their own conclusions. They brought in a team of about half of the team were blue patch wearing, no kidding, test pilots and test wizzos. And the other half were mostly gray patch, OT, very competent pilots, but not test pilots. They hadn't been trained. And I was always worried about that program execution. I had very smart guys on the ground at Holloman that were overseeing this, that were my people, all great test pilots. And they had flown all the different variants. I had some of my very best flight test engineers down there setting up the test cards and doing all of the analysis and the data collection, all the due diligence that you do when you're trying to put together a good technical report. And then there were these operational guys who knew tactics and warfighting and had, been fighting in Afghanistan and knew how to do close air support. And their insights into the tactics, I think, is what made them valuable to the team. But what we were really doing was doing a flight test. And we were not doing exactly what these other air forces had done. We'd flown the T-6, for instance, as a trainer, but not really as a weapon delivery platform. And the Super Tucanos were being used. We had actually sold them to the Afghan Air Force. Said, hey, here's a good, entry level weapon delivery, close air support, for when we leave, you guys could pick this up and you ought to be able to handle this kind of an expense and this kind of training and things like that. So it was supposed to be a known product, but like we always do, and General Eisenhower, when he puts out his caution in 1961 of what to watch out for, he says, watch out for the military industrial complex. He doesn't say, watch out for the industrial complex. He says, watch out for the military industrial complex. There's two parts. And when you put those two parts together, there's a potential for things to go off the rails. Well, the military part, in my opinion, is the part that went off the rails. They just wanted this so bad. They wanted a cheapo platform to help them solve their pilot shortage problem, because they just didn't have cockpits enough to get people the experience. And then theoretically, they would move out of this light attack platform into one of the frontline fighters, and that's how they were going to solve that problem, because there just weren't enough frontline fighter cockpits available anymore. The Air Force had shrunk, and so there were a lot of really good reasons to have a light attack platform, but we kind of went about it in a running with scissors sort of way. And I kept my fingers crossed the whole time, going, please, please, at least put, real trained test pilots in for the real hairy missions. And the response I got back from senior leadership, leaders above my level, was, super, there you go again. You're just trying to make this drag on and drag on. It's just going to cost a bunch of money. And in the end, you're going to say it was fine all along. We're just pressing. And we're going to have DT test pilots there, but we're also going to have OT test pilots, because they're test pilots too. DT and OT are combined now. We're not going to do a DT phase, and then when it's all figured out and the major bugs are identified and fixed, pass it on to OT as an operationally representative platform. We're just going to do all the OT points and the DT points together, and test is test, right? There's no OT, DT. It's all test is just test. So we're not going to do things twice. And they didn't understand that DT answers a particular question and OT answers a completely different question. They might be doing similar things, but they're answering different questions. And so the instrumentation and math and all that stuff on the DT side doesn't translate over to the OT side. And the OT tactical acumen doesn't really apply to something that we're just trying to figure out whether it works or not. So DT answers the question, does it work? And if not, why? And OT answers the question, can we use it? And if so, how? And you'd kind of do similar kind of profiles sometimes, but the answers are completely different and the tests are completely different. And the requirements for who conducts the tests are completely different. In our rush to fix these real problems, we said, you know what, these OT test pilots, they're not really test pilots. They're test subjects. They are they're just as good as DT test pilots. We're just going to have them do it. They've dropped 1 million bombs over Afghanistan, and they know what they're doing. Well, they don't. And it turns out tragically that they didn't. Envelope expansion is one thing that DT test pilots are taught at test pilot school. They get rigorous academics, math, and I mean, serious Greek letters and calculus equations and all the stuff that makes it hard, right? The reason why almost all gray patch wearers can't even apply to the Air Force test pilot school because they don't have the math skills. They're not engineers or scientists. They're not trained for it. They can't really understand the math behind it. Anyway, DT test pilots get all that academics. And then what makes the test pilot school really world class and better than, say, MIT, which teaches all the academics correctly. But the test pilot school then takes the person who's just gotten the academics and puts them in an F-16 and says, and they load it up asymmetrically, for instance. And they go, do you feel that? Do you see what we were talking about when we were talking about moments of inertia and limit cycle oscillations and all of these different technical things? And then they'll put them in inverted spins, and they'll teach them the difference between a spin and a accelerated spiral. All of these different things that are important to know. You need to have sort of a muscle memory where you go, I've seen this before. I know exactly what this is, and I know exactly what to do about it. So if you're a blue patch test pilot, you've had all that. You've already demonstrated proficiency, and you know the math behind the phenomenon that you're about to do. If you're an OT guy, you have a tactical acumen that maybe the DT guys don't have, but you really don't understand the aerodynamics and all of that to the degree that you need to make a split-second decision when you get into a place where you have no experience, you've never seen this before. DT test pilots are taught all of this and given experience. So when you are in a Super Tucano and you drop a 500-pound weapon, that's a significant amount of mass lost from one side of a not very big airplane with a not very big tail that wasn't designed to fly with all these asymmetric loads, and you're at slow speed, a speed that's never been flown before. What we really ended up doing was we put an OT guy in a position that his leadership had not prepared him for. And that's leadership malpractice. Flight testing is dangerous, but at least we prepare you for that danger. And we give you a fighting chance. When you put a very good pilot in a situation where he's doing envelope expansion, seeing a flight condition for the very first time it's ever been experienced, and then the airplane goes out of control at 1,000 feet above the ground for the very first time, it's just, it's what keeps me up at night. It happened on my watch. I was the test center commander. I was insufficient in my arguments to convince the 4 stars above me that this was a bad idea. And now there's a couple of kids out there that are growing up without a really awesome dad forever. And what's really tragic about it is those Super Tucanos actually came into the Air Force inventory We bought 3 of them. AFSOC took them over. AFSOC, I think, bought them because they wanted to explore this sort of lighter aircraft for their kind of special operations thing. And they already threw them away. It was a shiny toy, and they already said, well, we're going in another direction. So you tell me, was it worth it? Or did you just really want that BB gun so bad for Christmas? That's what eats at me. And AFSOC is known for doing that. A lot of people go, I wish I was in AFSOC. They just buy stuff. I wish we could do that. Why can't we do that, Super? You know, I went down to Hurlburt Field, and I was poking around one of their U model AC-130s one day. Somebody was walking me around, and I point to this gadget that's hanging on the wall and go, what's this do? Yeah, well, that's a PLS. We've pulled and collared all the circuit breakers for that. That doesn't work. Well, what does this do? Well, yeah, that didn't work out. And yeah, it's like they're shopping in the back pages of Soldier of Fortune magazine for the latest shiny thing. And AFSOC has a different funding stream that has a different oversight. They have the ability to just buy stuff, but they buy a lot of bad stuff, and they end up throwing it away almost immediately. They've already turned to a different light attack airframe. It's a converted crop duster, which they just crashed in Oklahoma just a couple of days ago. Forced landing, I guess it was. And I don't know what the cause was or anything like that. But if they keep up with their, if past is prologue, they'll throw that one away too. And they'll just move on to something else. Is that for peacetime, right? Is that the kind of Air Force we want, where we're just cobbling stuff together because General so-and-so thought it looked cool or might scratch his itch? Famously, AFSOC wanted to put a chin-mounted steerable machine gun on their CV-22s, these tilt rotor things. Well, in order to do that, they had to move the radar altimeter antenna, which was on the belly of the CV-22, to a different location, and they just did it. And it ruined their terrain following radar. So now they can't do terrain following. The entire fleet stood down while they undid their good idea that had not gone through the technical wickets. You really do need to do the due diligence, but sometimes the unbridled avarice gets in the way, and you can't go too far one way, you can't go too far the other way, but you got to balance those two requirements. And the combined DTOT, I'm kind of on board with some of that. We used to fly combined DTOT in the bombers all the time. When I was a squadron commander, we'd have a DT pilot and an OT co-pilot, a DT OSO, and then an OT DSO, defensive systems officer, in the B1, the B-52, multi-place airplanes. You can do a lot of DT-OT and combine up, and it's good. It's good for OT to see what's coming, and it gives the DT guys some insight into the technical side of things, how it would be employed, and and therefore what's an important deficiency report and what's not so important. So that kind of DT-OT combining together is good. It's when you say they're the same that you can get off the rails. What ends up happening is the DT pilots, and they love to do this tactical stuff because it reminds them of the days before they went to test pilot school, right? There I was, 4v4, wall of egos against, they love that stuff. And they're, doing all the two-circle maneuvering that they get taught and dogfighting and all that. It's very fun, and the DT pilots love it. The problem is the DT pilots are too good. And that probably sounds a little bit weird, but remember what OT is supposed to be. Operational test is supposed to be with a combat representative gadget, an airplane, for instance, and a combat representative pilot or aircrew member. And they're supposed to be paired together to go, okay, let's pretend like we're doing this in a war. Can you pull it off? Just like Joe Bag of Donuts out on the front line, not Steve Canyon, the Golden Arm test pilot, just Joe Bag of Donuts. Well, when you get Steve Canyon in the cockpit, they can make anything fly fine, right? They can't even help it. It's not even conscious to them. They compensate for badness all the time. And the contractors loved it when the DT pilots would fly their OT lines because they knew that the DT pilots would unconsciously compensate for their poor products. And they'd be able to pass because the DT guys were just too good. But it's bad data, right? It's not, it's a unpleasant surprise when you then pass it off to Joe Bag of Donuts and he fails or she fails. And the opposite is true. You get the OT guys, like what happened in the light attack experiment, doing DT operations, envelope expansion with an asymmetric load in an airplane that wasn't designed for that. And they auger in. And now I got orphans out there forever for an airplane that they didn't even keep for more than like 5 years. They just threw it away. That's a travesty. So that's my problem with combined DT-OT. And you'll get comments, I'm sure. I don't even read your comments because they just make me mad sometimes. And if you have a question from the comments, you can ask me, but I'm not going to read them because comments are from sources that I don't know and I don't know that I can trust. So I don't even pollute my brain with it. It's not all bad news though. And I kind of wanted to use an example from recent history to show you how flight tests should be happening. Developmental flight tests should be happening. You remember it was about a year, maybe a little bit more ago. They sent 2 actual real test pilots up in the Starliner. This is the spacecraft that's designed for the Artemis program and to go on to Mars. This is the program that was funded when George W. Bush 20 years ago pulled the plug on the space shuttle program and said, we're through dorking around in low Earth orbit. We're going somewhere from now on. So the space shuttle money shifted over to the design of SLS, and the Starliner is the command module from the Apollo days. It's just a tech refresh on the command module. Anyway, that's been in development for since then 20 years in a cost plus contract from NASA to Boeing to develop this spacecraft. And it's been a cash cow for them all the time. I don't know if you know contracts very much, but a cost plus contract is the contractor's dream. They are given something to do, and what they do is they tally up all the expenses that they did on their, for the last whatever time period, and they submit that to the government, and the government reimburses all of their costs plus a profit, and that's all negotiated in the contract. So there's no way for the contractor to lose money. And as long as it takes, they're making money. And if they make a mistake, the government pays them to fix their mistake. Who wouldn't want that deal? And when you're comfortable, you just make bad products. Eventually, Congress is like, hey, we're tired of paying your bills. I want to see the Starship fly. You promised that it would fly in this year, and now it's like X number of years later. Fly it, for Pete's sake. So they finally fly it, and they're going to go up to the space station, dock with the space station, be there for about 3 days. Then the 2 test pilots will get back in and fly it back just to prove that it works like it was supposed to. It was just a total goat rope the whole way. All these reaction control thrusters were dropping offline as they're approaching the ISS. The ISS is like, don't crash into us. And the guys on board are like, what are we? It was bad. And if you ever listen to the interviews, especially the ones who've retired and can speak a little bit more freely, they're like, oh, that was, I'm a test pilot and I was scared. That was not okay. And sure enough, they have all these problems, all these reaction controls. The controls themselves are just not working. But they finally managed to get it docked up. And those 2 test pilots end up staying on the space station for 9 months instead of 3 days. And they send the Starliner, the little command module thing, back unoccupied because they don't trust that it's not going to kill them on the way back. So that's flight test when the company is spending the taxpayers' money. Now compare that on the very, very same day that Butch and Sonny are trying to dock with the space station. The very same day, Elon Musk and SpaceX launch one of their Starship flights. And it's not even supposed to go into orbit, right? They're just testing whether they can get the upper stage, the Starship, to re-enter under control and do its thing. And it goes up, and a few things bad happen, and eventually it's re-entering the atmosphere, and all this plasma is coming off of it, and we have these beautiful, high quality images from their Starlink satellites the whole way, and it starts to tumble, and things start melting, and big chunks of spaceship are flying off, and then they show the control room with all the engineers that have designed this thing, and you would think that they would be like, oh no, look, oh, this is a disaster. jumping up and down, high-fiving each other, hugging each other. Woohoo! Because all those pressure transducers and temperature transducers and vibration accelerometer, all the instrumentation for all the structure is just pouring data into their data recorders right now. They know exactly what's happening to this, stringer and this rib and this. They've got all the data they need to know exactly what went wrong and how to fix it. And the engineers are just woo. And what's killing me is Elon Musk is going woo, and he's the one who's paying the bill. He's like, you would think he'd be like, you're fired and you're fired and you're fired and you're fired. And I'm starting over with a new team because you guys can't hack it. No, he's like, this is awesome. This is exactly what we wanted to happen, right? They're not putting astronauts up in that thing. They're not even putting paying satellite customers up in that thing. They know it's going to be dorked up. But they're learning, right? They're gaining knowledge this whole time. So watch the difference in how people operate. If you, the company, is paying the bill, you actually end up testing more. If you, the company, is being paid by, say, a government contract, you want less tests because that's an opportunity to expose failure. More tests is better, and SpaceX's record proves it. They're making money hand over fist, but they crashed Falcon 9 like 19 times in a row before they got it to land on the thing. They know how to do tests, and it's supposed to be dorked up, but they're gaining knowledge. It's when the company starts going, I don't want you to see my warts. Let's not do the test. Let's just send it. I'm sure it'll be fine. That's when you get worried. I've got my own little story about IRAD. It's called Internal Research and Development. This is what companies do on their own dime. When they're doing their own dime, good flight tests actually happens. Back in, I think it was 2007 or so, one of the big primes, and I won't even say who it was, were trying to figure out how they were going to compete for the big bomber contract that they knew was coming up. And they wanted to develop a design proposal that they could show the Air Force leadership and say, we've done some research on this. We think this is viable. We think you ought to hire us and do this concept. Well, one of the concepts that they were exploring was a supersonic weapon delivery bomber. So like a B-2, like I was telling you about in part one, that could open up its bomb bay door and all these JDAM 500-pounders come out and they all know where they're going to. And it's pretty awesome. But they wanted to do it supersonic. What would that bomber look like? Well, they have a problem because in bombers, especially a stealth bomber, you need to close everything up and make it nice and smooth. And all the weapons are carried internally. So when you get over the target, you open up the weapons bay and you kick the bombs out of the weapons bay and attack the target. Well, they wanted to test their design for this weapon separation technology that they had. There's a whole science into getting weapons away from the airplane far enough before they come back and hit it. But they needed to get up to Mach 2 plus with their little weapons bay experiment. So they come to the high-speed test track at Holloman, and that's what we do. We get things up to speed, and then we take all kinds of pictures and measure all the different parameters and give that data back to whoever is interested. So picture, if you will, and I think I sent you a picture. This thing is about the size of a bus, one of the short school buses. And it's pretty big. We can't have the bombs fall out the bottom like a bomber would, because it's on a rocket sled on a track. So we invert the whole experiment, and we have this weapons bay on the roof, and 500-pound JDAM shape, a mass model of a 500-pound bomb. And it's going to be kicked out vertically by a couple of pistons with 5,000 PSI compressed air. And they're just going to kick this thing out the top. And it's going to go from, we get this thing going, Mach 2, a little bit higher than Mach 2. The bomb kicks out and goes from 0 airspeed to Mach 2 through a bunch of shock waves and expansion waves because of the supersonic flow. And that's the experiment. And we're going to take a bunch of pictures of the bomb as it comes out. We're going to measure the temperatures and pressures and the vibrations and acoustics inside the weapons bay, and we're going to get all this data so that you can design your future bomber. So in order to get the school bus going Mach 2, you have to have rockets behind it to get it to go. So there's two rocket cars, a first stage and a second stage. The first stage gets it up to speed, and the second stage sustains it at speed. And then there's the third car, the experiment itself. So all I need is the bomb coming from 0 airspeed to Mach 2 plus, and then the experiment is over, and Boeing's happy. But I'm not happy because I'm the group commander in charge of the high-speed test track, which is one of my squadrons. And I have a very expensive test track. And when you kick out something that's going Mach 2, 500 pounds of that's a lot of kinetic energy. And I don't want the kinetic energy being dissipated for miles as it clatters along the test track up ahead of it. So I got to get rid of this bomb somehow after the experiment is over. And I turn to my test track engineers there at Holloman Air Force Base, and they're like the most amazing people I've ever met. This guy comes to me and he says, "Hey, Colonel Harris, I was kicking around on my home computer with this experiment, and I wire meshed the bomb bay and did all that, and I ran some Monte Carlo simulations of this bomb, and I'm thinking that it might be a little bit unstable, a little bit hard to predict. I ran 10,000 Monte Carlo simulations." This guy is wearing a Western plaid shirt and a big old belt buckle size of a dinner plate, and the Lee jeans and this cowboy boots with mud all over them, and he's the aero engineer. These are the people that's typical for the test track guys. They live in southern New Mexico in the high desert. They're cowboys, but they're also computational fluid dynamicists as their day job. This very same guy, by the way, like a week later says, "Hey, Colonel Harris, it's that time of year this Saturday where we're cutting the testicles off of all the bulls in my cow herd. You want to come and help us hold them still up at my ranch?" And this is the computational fluid dynamicist, right? He's got like a herd of cows and he has to, turn them into steers. That's my experience at Holloman. But anyway, he comes up with all this, and I'm like, oh, this is not looking good. I don't want this bomb to ruin the track. So I asked Boeing to run the simulations of the flight path, And I asked Seek Eagle at Eglin to do the same thing in parallel, because I could not have this bomb clattering down the track. And they all came up with a flight path, and it's like those hurricane tracks. There's spaghetti tracks that branch out based on probabilities and chaos theory and all this stuff. Well, we got the predictions to converge to a point where they were going to pass through like a 2-foot square, circle. And I said, okay, so come up with a way to get rid of this bomb so it doesn't ruin the track. Well, it's too much energy to just catch it like a catcher's mitt in baseball. So they came up with this idea: we're just going to divert it off to one side and let it just clatter to a stop out there in the desert. And we're going to do it by putting up a diverter plate. It's 4-inch thick battleship armor, big steel plate. And it's going to be hanging down there at an angle, so when the bomb hits it, the bomb bounces off to the side. But the diverter plate was really heavy, and it's actually turned out that the energy was enough that we couldn't build a structure to hold it up economically that was strong enough to keep it in place. So we came up with this idea of having these L-shaped brackets. And it was just hanging on these L-shaped brackets so that when the bomb hits, the bomb bounces off to the side and the diverter plate bounces off the brackets and falls down in the desert on the other side. That's how we're going to get rid of the bomb. And so we end up running the experiment. And that morning, the host wing commander for Holloman, there was 3 squadrons of F-117s down there, and the wing commander was a guy named Dave Goldfein, Fingers Goldfein. Went on to be Chief of Staff of the Air Force. He's the installation commander, and I'm a tenant organization on his airbase. And his boss is coming to visit Holloman to see what's going on at Holloman. So General Goldfein, he's a baby 1-star. I'm a baby 06, a full colonel, group commander. General Goldfein calls me up and says, "Hey, Super, you mind if I bring General Sipe up? He's the 12th Air Force commander. He wants to see what's going on at Holloman." And so he does. And we're all standing there at the place where the bomb's supposed to come out, and the rockets fire, and it goes up to Mach 2 and whoosh, goes past, and I'm supposed to hear this big gong go off, and the bomb falls off, and the gong and the rocket sled just keeps going. Well, remember what I said: the first stage pushes it up to speed, and the second stage continues. So the first stage burns out and is now coasting on the tracks behind it, gradually slowing down to because its propulsion is burned out. And the second stage is continuing to push this experiment at Mach 2. What ended up happening was the bomb comes out. It's supposed to come out level and just go from 0 airspeed to Mach 2, test over. But it comes out like this, nose up, and it just starts flying. And it ends up going too high. All of my predictions, right? Seek Eagle, Boeing, they get it all wrong. And the bomb goes too high, and it actually shacks the little erector set bridge that we had built to hold this giant deflector plate up. Right through it, which is enough to get these L-shaped brackets. The deflector plate slips off both of them, and it just comes down like a guillotine on this test track. But that's okay. The rocket sled is already passed by, except the first stage is now slowing down from Mach 2 and zorching by just as this guillotine comes through, and it hits this deflector plate and tumbles through the air and lands in this big cloud of dust. And so there's the 12th Air Force commander, 2-star, a 1-star installation commander, my lieutenant engineer who designed the rocket sled, me, the technical director of the track, all standing there. And I turned to General Goldfein and I said, well, that didn't go quite like we expected it to. And you know, it's just a disaster, right? A big cloud of dust and stuff flying through the air, and it was terrible. But I have a smile on my face, and General Goldfein's like, super, why? What? And I said, well, when it doesn't go well, that's when TESS earns its money. We'll figure out why it didn't go well, and we'll be smarter for it. So that night we're having this soiree at General Goldfein's house and all the group commanders are there. And I now have a CD of the high-speed video of this happening, because it's all happening just so fast. It's just zorching by at Mach 2, and there's this big sonic boom. Anyway, so I see all the high-speed video, and slow it way down, and you see this bomb come out, and it goes, whoop, and then it just keeps going up, and it goes right through the bridge that's holding the plate down. The plate comes down like a guillotine. The first stage of the rocket sled slams into it, because the bomb's not supposed to do that, right? It's supposed to just come up and then hit the deflector plate. Well, it turns out, and there's a very good paper on this at the Society of Experimental Test Pilots that was done by my squadron commander for the test track. And she did a great job putting this together, but they pull all this data from the weapons bay, and they understand now that there's this moving shock wave inside of a supersonic weapons bay. And it just was by luck that the shock wave happened to be in the place where the nose came up. It could have come out tail up, or it could have just come up straight, and we never would have realized this. But because we did this test, now we understood this whole new physics phenomenon that no one had known before. It's in none of the models that predict the flight path of these weapons. So that's how science moves forward. It's based on realizing that you're dorked up, your models are wrong, and you've got to update your models. So I'm happy about this, although I have to make phone calls up the chain to say, hey, I just chopped the test track with a 4-ton piece of battleship steel. We're working on fixing that. Sorry. But Goldfein's he's like apologizing to me. Oh, super. I feel so bad that General Sipe saw your failed experiment. And I'm like, no, it's not a failure. Don't you get it? We discovered something that we never knew was even out there. That's not a failure. And it's totally worth the damage to the track to find this new thing. But if you're an operational guy, you're like, no, it's a failure. If it doesn't work, it failed. If you're a DT guy and it fails, you go, well, there's a lieutenant out there is never going to see this problem because we're going to fix it right now. That's how DT is supposed to work. Anyway, I got a little bit off the track here, but that's really important. And people who are not technical people, they kind of don't understand how science works sometimes. They just assume that when you pay the money, you get what you paid for. but when it comes off the production line, it's not very good. It needs to be refined. It needs to be developed before it's any good. And then it can be really awesome.
Let me ask you a question around that then. So you describe in your framework, point 4 is this DevOps piece, minimal viable product. It sounds as though that could be assistive in a sense then. If you don't take a product from concept or inception through to, a sort of 90% complete thing, and actually you fail early and you use these cliches, fail fast, fail early, that kind of stuff. Sure. Do you, if you do it properly, then can you actually simplify the development test task because you are able to break things down into a more granular shape? Or do you actually want to see the completed or near completed product before you start developmental tests, because the various elements, the radar, the sensors, the airframe, the harmonics, all those things affect one another?
Yeah. Well, DT is that, right? That's the fail early. What you want is to fail with no consequence or minimal consequence. If you fail late, it's super expensive to go back and retrofit, sometimes impossible to retrofit. That's why we were trying to get rid of all those F-22s. We found problems in development that you can't economically fix now. They're already built. So you want your DT to be the fail early iterative process where you do this. This is the Elon Musk SpaceX model. They're failing early. They're fixing. They're flying again. They've flown that thing 11 times with no paying customers. They're paying all those bills out of SpaceX. And they haven't even been to orbit yet because they know how to do tests right. The other model is let's just send them in viable product out, not to test, but to the field. And we'll cross our fingers and hope it all works. And if it doesn't, then we'll go back and we'll use the screams of agony from the frontline Joe Bag of Donuts people to decide what we're going to fix first, second, third, and fourth. If I'm sending my grandson to the front line in that airplane, I got a problem with that.
So to be clear then, there isn't in and of itself an issue with MVP or being agile or being lean. It is the removal of developmental tests from the development process that is the issue.
The MVP should go to developmental tests so that it can get fixed. And then when all the fixes are in, you go to the field. Now, the problem, if you consolidate all of your industry down to just 5 mega companies, they don't want to pass a test. They know their quality's gone down. And so this is the kind of behavior that you'll get. They'll start saying things like, well, we don't want to test the T7 or the KC-46 or whatever. We don't want to test that at Edwards Air Force Base. We want to do those tests here at Boeing Field or here in St. Louis. As soon as that happens, if I'm a general officer and I'm paying the bill and I want this thing, red flags. Boop, 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 boop. Something bad's happening. What that means is the company doesn't believe in its own product. And this is exactly what happened in KC-46 and in T7. They said, no, we want to do all the tests at our production facility. And you guys can send your developmental testers to Seattle, or you send them to St. Louis. And what ends up happening is the doors start closing and saying, no, this is Boeing proprietary. The government can't be here. And when the door closes, the government has no insight into what's really going on. But I can pretty much guess that what's really going on is them saying, don't let the government guys see this. We will totally fail any kind of test. So we got to come up with a way to get out of the test. We'll send our lobbyists to Congress. We'll send our influencers to the Pentagon, and we'll convince them that it's the test that's making us be late. Yep. It's the test that is the problem. And we'll just send our product out. We'll tell them that that's how to make it, the acquisition process run smoother and faster. And we bought it. We're totally being played by the contractors. We're just being played.
You go, sweetie. Okay. All right. Mum will be home soon. Yeah. What else can you have? Just go and have a banana or something. You have a banana? She eats all the time. Yeah, so you mentioned T7, KC-46. Yeah. Those are, there is nobody singling any particular contractor out for special attention, but those are two very public profile programs at the moment. T7 is flight control issues around high angle of attack, 3 years at least behind where it should be. Issues with the ejection seat, a bunch of things going on with that. I was kind of concerned to read today a British analyst saying that T7 would be a good fit for the RAF, and I was thinking, no, we want to stay well away from that thing. There are other options, but anyway, that's an aside. KC-46 has some issues as well. Booms falling off, inability to refuel in certain regimes. So are you seeing any program at the moment, any major defense program in the US from an aerospace point of view that is not affected by these things that you're describing? Can you pin the tail on the donkey and say, for example, with T7 or with KC-46, if the DT piece had been done correctly, if they weren't trying to do concurrent development, if they weren't looking for MVP, if the stages that you've described were not there, that everything would be fine and they would be on track?
Probably the best run program in the DoD right now that I'm aware of is the B-21 program. B-21 actually is being handled a lot like the good old days. The early performance and flying qualities tests are being done at Edwards right now, and that's proceeding very well. I understand that there's a second B-21 that's been delivered that's going to be not instrumented for flight sciences as much as it will be for integration of the weapon systems and the sensors and the communications packages and things like that. Keep an eye on that one, because getting something to fly is actually the easy part. It's probably the most dangerous part, but it's also engineering-wise the easiest and best understood. Getting the sensors and comms and data all talking to each other correctly, that's the hard part. So watch this second airplane, and I'll bet you're going to start to see problems develop. But that program seems to be executing closer to the way it used to be, right? They're not just going to start the full-scale production line and just hope for the best. They're doing deliberate development, and that one's being run well. I know it's being run well because the guy who sat next to me at test pilot school is a program manager. He's the guy in charge. He's actually the acting acquisition secretary for the Air Force now. Super good, honorable, he knows exactly how to do it, and he'll resist these tendencies that the contractors are putting out. But we haven't got to the hard part of B-21 yet. I would say that one's running well. KC-46, that was the program that was supposed to hit IOC when I was the 2-star at Edwards. It was supposed to be good to go like 2018. All we were going to do, this was not supposed to be hard, right? It's technology that we developed. Our great grandparents had developed it in the 1950s. Flying booms, aerial tanking, probe and drogue, all that. It's not hard. We're just doing a tech refresh. Well, the 767 part of the KC-46, awesome. Boeing makes a very good commercial airline product. It's all the refueling parts were totally dorked up. Every single one. Wing, air refueling pods. Couldn't take up the slack on the hose when the F-18 mated with it. And this transverse wave went up to the wing, back down to the airplane, broke the probe off, and started bludgeoning the F-18 test pilot with it, like a billy club. The remote vision system saturated whenever you turn the tail toward the sun. So we can't have a tanker that can only refuel when it's faced away from into the sun. We can't do that. Why they don't just have a guy in a chair looking through a window? That's pretty low risk. We got to have them up in the cockpit with these 3D glasses on, looking at this. They can't find the probe, so they're scratching the stealth coatings off the stealth airplanes with the end of the boom, and we can't have that. Just everything about even the place where all the luggage goes in the 767 airliner, that all got turned into fuel tanks. All those tanks were not in the normal Boeing assembly line. They're all done bespoke.
Are they?
And there's all kinds of like FOD and crap in there. It's just not good. And I went to tour the facility up there, and the guys that build the boom, you think that's Boeing building the boom. All these things are built by Boeing subcontractors. And some of them are just not very good. You would think that boom would be built by robots with high tolerances, and no, it's like 3 guys. And if it doesn't quite fit, they just take a mallet. And it was concerning to me. And then earlier this summer, F-22s refueling off the East Coast, and the boom just falls off in the middle of refueling an F-22. And I'm like, not surprised, totally not surprised. It's just so bad. I remember as sitting at test pilot school eating lunch one day, and one of the test pilots comes into the bar there at test pilot school, and he flops down in a chair next to me. He'd just come from the T7, which had just moved out of the Boeing facility over to Edwards for their tests, and they're just finding all kinds of problems. And he flops down and goes, "Oh, super. I can't even begin to tell you how effed we all are."
Wow.
And I kind of knew, because I was developing a lab for the students to do. We take them to right now we do it in the F-16, and we have them run some tests, And there's some known problems that we have the students find, and they have to write a deficiency report. This is how we teach them how to write up a deficiency report so that it makes sense. So I was going to update that lab from F-16 to T-7 because that was a more relevant modern example. So I go over there to their sim facility. I'm sorry, T-7 guys. I know you love the T-7, and I'm not really trying to pick on one contractor, but it's just like the JV team put that thing together. The software is just terrible. And it just seems so chintzy and slapdash to me compared to the other products that I've flown.
So before we get on then, Super, to talking about F-35, because I'd like to get your views on that too. Can I just take you back quickly to the light attack experiment and the conversation that we were having, or your description of those things from your perspective as a very senior individual in that process? You talked about sending your best flight test engineers to go and do the maths and to document everything and create the test cards, and you did have test pilots there too. And as I had said to you previously, this is the 10% True podcast is not a podcast that's designed to make people pit people against each other, make people feel uncomfortable, feel harassed, or otherwise be challenged. But I did want to ask about one thing that Starbaby had recited or recounted from his perspective in the light attack experiments, which was having a test pilot there who wanted to use some of his precious stock of GBU-12 and him having to have a word about that. Is there usually any natural tension between development test, operational test? Is that kind of thing commonplace? Would you expect to hear somebody who's more focused on the operational side of things saying, hey, those are our resources, leave them alone? And does that play a part then, or could that have played a part in the route that you've seen operational test, development test, and test take over the years?
Mm-hmm. Now, that's an excellent question, and something that we in the test community have been struggling with since its inception. Test was actually invented, government oversight test for the U.S. military was actually started in 1943 at the height of World War II. So I lose a little patience when everybody says, Super, all this test is fine for peace, the Pax Americana, but the Chinese are coming over the backyard fence any day now, and you just need to take a back seat until we're through this. Well, 1943 was at the highest existential threat the world has faced, and that's when they decided to start it, right? And it was triggered by a crash of a B-29 into a meatpacking plant in Seattle because the engines had caught on fire. Wow. And Congress put together a committee. It was actually chaired by Senator Harry Truman, who later became President Harry Truman, who dropped the first atomic bomb using the B-29, which was being built specifically for that weapon. It was the only bomber big enough for that weapon. And the whole Manhattan Project cost, I think, $2 million in World War II dollars, and the B-29 program was $3 billion. Wow. So more than the whole Manhattan Project. And when this top secret bomber crashed into a meat packing plant and killed 22 people, plus all the people on board the B-29, including their chief test pilot and designer, that's when they said, you know what, we're going to have the government check homework from now on, operational and developmental. And so those two branches sort of branched off a little bit. And Congress, around the time of the Vietnam War, got so fed up with the complaints from widows and grieving parents about weapons that failed in actual combat that they codified operational tests in the US code. You must do the operational test. Now, the code never says that you have to do developmental tests. You can skip developmental tests and just take risk. But you still have to pass the operational test. Now, there is a tension between DT and OT. DT is pretty sure that they're the kings of the world, and OT is pretty sure that they're the kings of the world. But in reality, we're so glad that both are on our side, right? We really do need each other, and it's not interchangeable. I remember, just to illustrate the point, and I was commander somewhere, and I got a call from the wing commander of a nearby airbase, and we shared the airspace. And they were pretty sure that we were screwing them, and we were pretty sure that they were screwing us for time, right? Just time to do our particular missions. And I remember their wing commander, she comes to me with her entourage of folks, and we meet in this secret space, and she's like, "Super, we've got an important mission. We gotta do this. And every time we want to go to a particular location, you guys have it scheduled." And I was like, "Yeah, we have it scheduled. We made this agreement like 20 years ago that you would have this block and we would have that block." And right? And she's like, "No, we need your block, and because our mission's important." And I said, "Okay, raise your hand if you think that new programs are just too fast and just too inexpensive." Nobody raises their hand, of course, because everybody knows that they take too long and they're always over budget. And I said, "Do you think a disruption in the flight test schedule is going to make that better or worse?" They went back and used their block and gave us our block. Now, and we developmental testers, we needle the OT guys, right? And I've said it a few times that the thing that gets their goat the most is our guys are test pilots, you guys are test subjects. And that's actually true for most OT. Now, you've flown with the 422 out at Nellis, right? Now, those guys are, their tails might say OT, but they're not really OT. They're not the OT that's codified in law. They are not Joe Bag of Donuts, operationally representative, just, airman snuffy kind of people. They are cream of the crop of the patch wearing world, right? But they're not operational testers. They're actually developmental testers. But what they're developing is tactics. They're tactics development. They're developmental testers. And we would never, developmental testers, blue patch wearing developmental testers, would never say we could do that job. That's not why we're there. That's not our job. That's not our mission at all. Although every test pilot who comes to test pilot school is an operationally accomplished in whatever they came from, right? They have, like 1,000 hours of time in frontline squadrons. They're not coming straight out of college. So they're not a bunch of eggheads that don't know how to fight a war. But tactics and all of that, they like to think that they know, but they're not on the cutting edge of that anymore after they've been in the developmental test world for a while. They're there to manage risk and to hold the contractor's feet to the fire when they deliver a shoddy product. That's their job. And they win their arguments not by Jedi mind tricks or rapier wit or oratory. They do it, and they do it by data. They just show the data and say, look, we did this. We pushed the button at this time. It's supposed to do this by the contract. Which you, the contractor, signed, right? You said you could do this on this time scale. It didn't do it. Fix it, or you don't get your money. That's what DT is really there for. Now, when we go to DevOps, what you really said was, we don't value that. We're trusting the glossy brochure put out by the contractor, and we're going to trust you with our lives and our combat success. So to me, this is how great empires fall, right? It's little things like this that just start to creep in, where you just lose your hunger, you lose your edge, and you start trusting people that aren't trustworthy. So real operational test is supposed to be done by operationally representative crews, not special, not highly gifted, just regular guys and gals. Now, I'll give it to you that if you're a fighter pilot on the front line, you are not average in the American population, right? And I don't want to make it sound like all we do is take a bunch of Walmart shoppers. We don't. It's a very hard screening process to get through all of the different steps to get to a place where you're an operationally representative pilot, let's say, or aircrew member or whatever. So I don't mean to insult, right? I know you're awesome, but you're not developmental test awesome, right? The reason why they got picked out of 3,000 applicants for 20 slots is not because they were operationally representative. It's because they can do the math, right? And fewer people can do the math. Actually take the hard classes in school and be able to converse with an engineer in terms that Isaac Newton could follow, right? So that's the real problem between DT and OT. And when we start to mix them and just say test is test, we really get off the rails pretty quickly, in my opinion.
Super. Tell us a bit about then your experience. We said we'd talk about Hegseth and F-35 though, and very briefly F-47. But before we do that, you said something when we were not recording yesterday about your experience at test pilot school. You retired in August 2018. I think you went straight to test pilot school. You were, I don't know what your title is, professor, lecturer, teacher, whatever it is, instructor at test pilot school, and you resigned fairly recently, early this year. What drove that? What experiences did you have?
Well, it was interesting. I'll tell you a little bit about my post-retirement career, and that kind of informs this question. I retired from active duty at the top of the pyramid for DT. I was the commander of all developmental tests, headquartered at Edwards, but located in 30 some odd locations, 18,000 people. It was a big enterprise. I retired and we moved back to where my wife and I grew up. Because her parents needed to be cared for. They needed long-term care. And we had time to be the long-term care providers. They ended up passing away within months of retirement, both very close to each other in time. And so I found myself retired, but still in the 2-year ethics window for general officers, flag officers. You have to cool off for 2 years before you can join into many of the industries that had contracts, so that the appearance is not the revolving door. Although, to be honest with you, the companies are perfectly willing to wait 2 years. And I mean, it's just a revolving door with 2 years off to go on cruises or whatever. They know who you are. And they approached me, right? Several of the big primes came to me, probably with the idea of, keep your friends close and your enemies closer. Because I have a reputation, and I'm sure it comes out a little bit. I'm not a huge fan of the products that have been coming out lately, and I think the system is a little bit not right. And I realized that it was not right when they'd come to me and they talk about compensation. And the money is very good. I mean, it's very good. But it wasn't the money that got me. It was the stock options that got me. They said, in order to keep you in a lower tax bracket, we will pay you a considerable part of your salary in stock options. And I'm not a super savvy, finance guy. I didn't know. So I had to look up, what's a stock option? Stock options are where the company gives you stock, but you can't sell the stock and take the money for it until a particular time in the future. Now, if the stock price has gone up, then you make money. If the stock price has gone down, then you lose money, and you have the option not to sell. So your personal income is now wedded to whether the stock price goes up. And that to me was, I couldn't live in that situation, because I'd lived my whole life pointing out flaws in products. And you can't point out flaws in products which need to be pointed out and think that the stock price isn't going to feel that. So now you're in an ethical bind. I want more money, but if I say the truth, I get less money. And I'm not, a bunch of my friends are working for defense contractors, and I don't mean to disparage them or imply that they're corrupt, but they live in a corrupting marinade, right? And to me, you just can't help but get some of that in you when you work in that environment. So I didn't do it. What I took while I was retired was a job at a university teaching business ethics.
Oh.
So I had to teach these students, and I had a ton of great examples of what not to do when it came to business ethics, right? I taught them all the Immanuel Kant and all the basics of ethical philosophy and Aristotle and Mill and all the, but it kind of comes down to whether you can live in your own skin. And I'm a retired two-star. I have a very nice retirement check. I don't live in a palace, but I have everything I need. I don't need my own private jet. I don't need a big McMansion. I don't need season tickets to the football game. That's not what makes life valuable to me. So I went to the test pilot school after teaching business ethics. They approached me and said, "Hey, Super, we have an open position for mission systems to be the mission systems instructor and to put the curriculum together for students, keep it fresh, keep it modern." And so I took that job and was thrilled to have it. I had just built a house up here in Utah, the one I'm sitting in right now. I'd lived in it for 2 months, and I took this job at Edwards. And if you've ever been to Edwards, you know why it's there, right? Edwards is there because when we take off, we're not entirely sure we're going to make it back ever, right? The whole thing about developmental test is that's the first time we ever tried this in a real airplane. And there's 500 smoking holes within 50 miles of that place since World War II. And that's not an exaggeration. It's the boondocks. It is out there where you can crash an airplane without hurting somebody. And I lived in this crummy little apartment, 1,000 square feet, but the job was worth it because I love developmental tests. The guys and gals that have graduated from that place are all my heroes, and they still are. But it's like a creeping cancer that is taking over, that values developmental tests less and less, sees developmental tests as a waste of time and money. They start using these high-speed graduates. These are the people that get selected for astronaut training, and I mean, they're the cream of the crop. And now they're being reduced to data takers, data scientists, the guys that hold the clipboard and mark tallies, when what they should be doing is acting like medical doctors, but only for machines. I see there's a problem. Let's dig through all of the circuitry. Let's figure out all of the physics. We'll help the engineers solve this problem so that it doesn't get out to the fleet, to the frontline troops. And that's, I told you yesterday that I signed up for test pilot school for selfish reasons. I wanted to be the first person to set foot on Mars. But it rapidly changed for me because I started realizing more and more that no one was able to speak for the lieutenant or the young captain who's just coming out of the basic course. And we're going to give them a product that their lives depend on. And I wasn't willing to sacrifice the quality of that product for somebody's stock price.
Mm.
It's just, that's not a trade I'm willing to take. But test pilot school got, there was a change in leadership. The leader was very charismatic, very smart, but he kind of didn't believe in the whole, at least in my estimation, didn't believe in the whole primary purpose of developmental test, which is be the voice for the voiceless lieutenant who has no power to say that this product is crap. Somebody's got to speak for them. And it's not going to be the general, right? The general just wants the BB gun so bad. Mm. And it's not going to be industry, because when push comes to shove, they're going to protect their stock price, and they have a fiduciary responsibility to their investors. Yeah. And I'm an investor, right? I want the company, a publicly traded company, to look out for me. But when looking out for the company and looking out for a brand new lieutenant coming out of the B course conflict, they always go for the stock price. And so the products get slapdash and poor. I mean, they're just poor. Hmm. And I'm afraid that we're just going to accept poor products as, well, that's what you get these days. Because they don't remember the old days. They don't remember the warfighting systems that we fought Desert Storm with. Hmm. They were the very best that we could make. And they really worked. But now with a loss of competition, they're just getting more and more expensive later and later because they're filled with problems. And it's just a spiral. And that spiral got to the test pilot school. They cut out 30% of their academic rigor and replaced it with a seminar on rhetoric. No, you don't win an argument with rhetoric. You win it with data that says, we tried it, it didn't work, right? Captains have been winning those arguments with lawyers in three-piece suits for 55 years. They're not going to do it with rhetoric or persuasiveness. We've gotten away from the whole collecting data thing and having that be a good thing. Now it's like a bad thing. Hmm. And I don't like the vector. I think it's coming around a little bit. The worst of it is probably over. And now you start to see little startup companies come out with some pretty darn good products that they developed in-house, not on government contracts. And those products are starting to challenge the big boys. And I think the big boys are starting to go, maybe we better reform a little bit. So it'll be interesting to see how it plays out. But for me, I'm past that time, I think. I don't think I'm going to be able to be influential anymore. And so it's time for me to start over, do something of service that isn't compromised. And that's where I'm coming from. So that's what I'm doing right now, finding ways to serve.
In regards to those smaller companies coming out with innovative ideas that have strong appeal, I mean, I think we're talking things like CCA. I know that there are some smaller companies working on propulsion. There are a bunch of things that are going on. Is there a danger that actually they'll just be snapped up by the big players?
They will be snapped up. As soon as they become a threat to their stock price, they'll be bought out. And that's just the American way. That's what happens. That's how all these startup unicorns get their $1 billion.
Do you
They
think
get
that's
bought by big companies.
Do you think that's true though? Super. Sorry to interrupt, but even though some of these companies have been set up by tech billionaires. I mean, you mentioned that I think before we hit record the other day, that's an interesting observation to make. These are individuals who are intensely driven to be successful on their own terms. You look at Musk. I mean, no one's managed to buy. I don't know if anyone's tried to, but no one's managed to buy his enterprises. Is that a ring of steel around them that would protect them from that? The fact that they're owned by individuals who don't need Boeing or Lockheed Martin or Northrop Grumman or whoever else to come along and offer them some money.
They're a rare breed. The Palmer Luckies, the Elon Musks, the Jeff Bezoses, that made their money somewhere else and have come into the defense sector sort of as a second or third enterprise option. But all of those examples are personalities. And just like when Steve Jobs died, Apple just wasn't Steve Jobs' Apple anymore. They're trying, right? They're really trying, but it's just not the same. When Elon Musk dies or when Palmer Luckey dies, what's going to be left? Just another contractor looking for a contract. And somebody else is going to have to come in and bubble up from below. So anything that encourages these smaller guys to come up from below, I think is good for competition and good for the warfighter. But you can't just have a good idea in a garage anymore. You have to have somebody who believes in you to the tune of multi-billion dollars to compete in this sector. And if you didn't make it in PayPal or Tesla or Oculus Vision VR goggles or some other outside of DoD enterprise, yeah, it's just super hard to break through these days.
Have you been? So we'll talk about Hegseth in just a minute and his proposals for, I think, what he called a reformation of defence acquisition. I think that was his title for it. But has government approached you? You talked about serving in the best way you can and your options, and it's up to you whether or not you share that. But have you been approached by government? Obviously, administrations change, priorities change. Everyone has priorities. Anyone come to you and said, "Hey, super, come and tell us, what do you think we should do?"
Not really. I'm a pretty little fish, and I have zero charisma, right? I'm not Patton. I'm not that guy. And so I don't even register. I don't think my name is bantied about in, I'm looking for the next undersecretary of the Air Force, or I'm looking. They're not looking for me. At least I don't think. Maybe somebody's going to watch this and I'll say something that makes them go, "Hey, that's the guy I want." But right now, my side of the view is the minority side. It is seen as obfuscation of progress. Mm-hmm. And so I'm not going to be super popular in government circles for either party, right? I'm not really going to fit in with the Hegseths of the world, and I don't play ball well enough to fit in with the other side. So I'll find another way. I'll find a more local way of serving, and we'll just see how it goes. But there are problems in just about anything. If you dip your foot in the water, it's like the book I was showing you.
Yeah.
You can step on an ethical slippery slope, and before you even realize it, you've become somebody that you don't want to be. And just every morning I have to ask myself, am I Nicholson? Did I turn into Colonel Nicholson today? Maybe so. Maybe I did.
Yeah, I to me, I don't. I think I said this to you last time around, and maybe we weren't recording, but I don't really agree with your characterizations of yourself. So I do think you're charismatic. I do think you've got a way about you. I think that the things you're saying are said from, are rooted in logic, but are said from the heart. And I think that you explained in the early parts of our first recording on this topic that you're concerned about the warfighter and you're concerned about the nation. If all these predictions about China ready to take Taiwan in 2027, you guys would get hammered if there was a peer conflict with them. They see the US as a tiger, or they started seeing the US as a paper tiger following that F-22 incident crossing the international date line. Those are. I mean, there are no better motivators. There's no better reason for wanting to get the message out. So I don't really see the same things in you as you see in you.
I'm flattered that you even asked me to do this, right? Because it's like my mom used to say when I was in high school. Oh, look, there's David. He's the only kid in the marching band who's in step. So I'm the only kid in the marching band who's in step. Maybe
that's brilliant.
maybe there's a place for that guy. But right now I am swimming upstream big time.
But everything needs a disruptor. Everybody. I mean, okay, maybe if you're just in the business of making lots of money, you don't want disruptors, but for the good of the lieutenant and the captain and the nation, you need that disruptor. So just tell us then quickly. We don't have time to go into F-35. I promised my son I'd make honeycomb with him. So there's a billion things about F-35 I'm sure you could say, and everybody knows F-35 and probably is familiar with its shortcomings, thanks to things like the Government Accountability Office and the reports that come out.
Yeah, did you see that? That GAO report was just like, bam, right in the nose. And I wish I could say they didn't deserve it, but they just do.
Yeah.
And it's fun. Well, I just very quickly, when increment 3, the contractor signs the increment 3, which is supposed to enable the F-35 to do all these future things in increment 4. They just don't deliver it. And the program executive officer gets mad and says, well, we're not going to accept them. We're just not going to give you the money. And Lockheed is still cranking them out. And this parking lot outside of their factory is filling up with F-35s and F-35s. And the PEO is like, not going to give you to them till you provide us what you promised you'd provide. And Lockheed saying, really? Are you sure about that? They deploy their armies of lobbyists and influencers and graphic designers and to convince everybody that it's the government's the problem, right? It's the government acquisition system's the problem. Not us. It's not us. Meanwhile, F-35s are filling up this parking lot in Fort Worth, Texas. Guess who blinks first? The government. And why? Because they're worried that a tornado is going to come through that parking lot and blow all those brand new F-35s with the new car smell to Oz. So they accepted them, knowing that they weren't capable of doing the mission that they contracted with the contractor to do.
Yeah.
They accepted them. we great powers don't last forever.
Yep.
Sometimes they just crumble from the inside.
Yeah.
And I'm a little bit worried about that.
And civilizations too, not just great powers, right. Civilizations.
Because I don't know who we turn it over to, right? And not to poke the Brits in the eye, but everybody wanted to be a Brit in the 1800s.
Yep.
And it was okay when they said, okay, America, we're exhausted, take over.
Yeah.
Who are we going to turn it over to?
Yeah. That's a depressing thought. Let's not go there. Hey, tell us. I made a quick list of the key points, I think, from Hegseth's Reformation speech. He talked about longer, bigger contracts. That doesn't sound like a good idea. Executives having accountability for acquisition programs and the success or failure of those. That sounds interesting. Rejecting frivolous claims. We briefly talked about KC-46. I didn't really ask you about whether it's okay to buy an Airbus product from the Europeans, even if it's Northrop Grumman that are going to build it or whatever. But
don't get me started. We could have such an awesome fleet of KC-40s right now. Have you seen that Australian thing? Oh man, that is a great tanker. We totally could have done that. But it was Americans that did it, right? It was people in Congress saying, I'm not going to have my profits going to Toulouse.
Yeah.
We got what we got.
Yeah. So on that then, just quickly, is that a completely insane position to take? I mean, America, from the outside looking in, America is the land of the free, the home of the brave. You're an intensely patriotic nation, America first. I get that, and in many ways I respect it, and in a lot of ways I wish we were more like that here, and we weren't so embarrassed about being British and English. But that aside, is it okay to just say, well, look, it needs to be built in the States because then or it needs to be an American product because then you do have control over it. You can influence it. You do own it. You don't have to go to someone else and say, mother, may I? Just quickly give us your view on it.
Right. Well, I mean, it's the same as the defense industrial complex. There's when there are so few competitors, you stop picking the guy who has the best proposal. And you start picking the guy whose turn it is. Because you have to keep all the plates spinning. You only have 5 plates. And if you give too much work to one, the other plate starts to wobble. So even if the other wobbling plate's product is poor, you have to pick them because you got to get it spinning again. The same thing could be said for nations. I'm perfectly comfortable with taking a foreign product if they have a better product. But if I was a congressman, especially if the factory was in my district or in my state, I would threaten to commit suicide on the steps of the Capitol building if they didn't give that work to my workers, right? My voters in my constituency. And that's exactly what happened. We had a signed deal.
Yeah.
They even made it look like it was kind of American. And the Buy American people were just like, no, we can't be having that. An Airbus product? No way. And they changed all the rules, right? The tried and true rules for competition, and made it happen. They just made it happen. And if you're that prime contractor now, and you have that contract that was made to happen, you know you are not threatened with being fired, no matter how poor your product is. There's nothing you can do that could be bad enough for them to say, that's it, we're going with Airbus. And that's exactly the product we got. They didn't have any reason. They had no competition. Mm. And when you have no competition, you just put out a bad product. It just happens. And I'm okay with foreign competition because it's competition.
Yeah.
It makes everybody better.
Yeah. Okay, so final question then, Super. I promise this is the final question because it's on a topic I don't want you to get yourself into any hot. Well, you obviously don't want to get in any hot water. You don't want to get yourself in any hot water. I definitely don't want to be responsible for getting it. But
I'm already sleeping.
But F-47 then. I mean, you talked about whose turn it was to be the spinning plate or keeping spinning plates. The public announcement that came out earlier in the year was that Boeing was going to be awarded a $20 billion manufacturing contract. They had put a few $1 billion of their own money into turning their factory in St. Louis into a classified facility so they can build this thing. So there was a little bit of investment that they had made before the contract has been awarded. That's interesting. But so that's the public position. The other thing that has been stated publicly is that there may be more than one version of this thing, and there may be more than one manufacturer of this thing. So I just want to ask you about those things. I don't want you to talk about anything else or feel like I'm asking you to comment on anything else. Does the award of a contract then to Boeing, because it's the Air Force wants, or the government rather wants to preserve its tactical fighter business and make sure that it can keep going for future generations, does that make sense in any way? Does, I mean, I have heard you, I'm hearing you say lack of competition is bad. It's bad for the warfighter. It's bad for the taxpayer. It's, it's great for the company, and that's all it's great for. But does preserving this institution, I mean, Boeing is now an institution, the combination of Mercaire and Douglas and these great companies from back in the day, they are now an institution. Does preserving that make sense? Does giving them the contract make sense?
It makes sense to an extent. The great British companies from the Victorian age, how many of them are your leading companies today?
Yeah, none.
None.
No.
Right? It's natural to have a peak and a natural death as a company. It happens to just about every company unless you keep it on artificial life support. And that's essentially what we've done, or what we're doing. The F-47, I think that's, both parts of that name are interesting. It is totally not an F, right? It's enormous, and the 47 part was like, where'd that come from? Oh, I think I know. I think I know. I'm not going to be more explicit than that. So those of us who are in the know this whole next generation air dominance fighter has been a thing. It's the follow-on for F-22. It's the normal progression, and it's kind of in the DNA of the DoD to do these replacements every couple 3 decades. And the F-22 came out in the early 2000s. It's time to start putting together another air dominance fighter. I'm okay with that. How we do it is the real key thing. So we start off pretty good, and we actually have the competitors put together a flyable, reasonably something that can meet the specifications notionally on the cheap, right? Just one of them. And then they have this competition, theoretically a competition. It's not really a competition because those of us who are in the know are watching the news. And when they awarded the contract for B-21, which is a big contract, that went to a particular contractor, and we all in the office turned to each other and said, all right, bets on when that particular contractor drops out of NGAD. What's the date, right? Everybody puts $5 in a pool because we all know it's going to happen. They wait a modest amount of time, and sure enough, one of the contractors says, you know what, we just can't compete in the next generation air dominance fighter. There's two competitors, we'll let them compete. They had the best proposal. They had the best product. It would have, well, in my opinion, they had the best product. But it wasn't their turn to win because they couldn't both win the fighter product and the bomber product contracts, because that would have been too much of the pie that went to one of the spinning plates. And so, sure enough, they voluntarily backed out of the competition, even though, in my opinion, they had the better product. Now, I'm not picking on Boeing. I actually think their product was the next best product. And so hopefully they'll do fine, right? The Boeing advanced products people, they actually have a pretty good team down there. The advanced products people, their varsity team. And they'll probably do a pretty good job putting this thing together. And we'll just have to see how it does in test, if they even have tests. By then, if we read Secretary Hegseth's manifesto for how acquisition should be reformed this year, acquisition gets reformed every year, and it has for the last 40 years, because that's an easy target. Oh, the government must be screwing it up. If you read that, there won't even be a competition. Boeing will just put out a min viable product and ship it. And somebody's grandkid is going to be flying that. I really hope that that's the environment that produces the next F-15, but I doubt it. I think it's going to be terrible, but that's just me. And I'll be dead by then, but not by my own hand. So we'll see. I hope America wins. I want America to win.
Vive l'America. Yeah.
That's right. I just worry about them. Sometimes they just don't help themselves. But that's just my opinion. And I'm just a private citizen, so I can't hurt anybody.
Okay. I have loads more questions. I'm not going to ask them, Super. It wouldn't be fair on you. And I promised it was my last question. I'm not gonna ask them. But maybe what we can do is in a few years' time, perhaps when we know more about F-47 and we see how it's going, and there's some more things that you're allowed to talk about, maybe we can get together and have a discussion and get a little insight from you into the things you're seeing, because obviously you've been very I'm assuming you've been very closely involved in it up until the point you retired, and so it would be nice if there are some insights that you can share with us that are no longer classified anyway. So look, but I think this has been a tremendous and a really important thing. I mean, I do the podcast for light entertainment and for historical record. I think that's probably the two things that I like to do it for, and you've provided us with both of those things, but also something much more important, which is something that's prescient, something that matters, and something I hope that people will, in the right positions with the right authority, will maybe pick up on, and perhaps it can make a small difference, if not a big one. So I appreciate you coming on and doing it, and it's been
thank you very much.
It's really been a joy to talk to you again. Thank you.
Well, likewise, it's always a pleasure, and I'm honored to have been trusted with this much time with the very tech savvy audience that your podcast draws. It means a lot to me. So thank you very much.